By the way, remember that SSH is only a protocol. Therefore, you can think of it more like a recipe for making a cake or any other baked good. If we continue to use the cake analogy, the actual cake that you can actually buy at any of your favorite software bakeries is a piece of software called OpenSSH. OpenSSH comes with a suite of tools that help us connect securely to remote servers using the SSH recipe, and in the process allows us to operate those remote machines. These tools can be grouped into 3 broad groups based on what they help us accomplish and how they do it. The SSHD and ssh-agent tools provide background services, with SSHD acting as the server that listens for SSH connections, while ssh-agent is an optional background service that stores private keys in memory to provide easy access. SSH Keyscan, ssh-keygen, and ssh-add provide users a way to manage SSH keys. And finally, SSH, SCP, and SFTP are tools that are used to carry out operations on remote servers, with the SSH tool being the workhorse of the bunch. So we'll begin by connecting to a server that I've already set up. It's already configured to listen for SSH connections, as the SSHD is already running and waiting for requests. As you can see, we get a host verification warning and get a prompt to confirm whether we want to proceed with connecting to the server. In simple terms, what is actually happening is that the SSH command is asking you, do you trust this server? If you confirm that you trust the server, the SSH command will collect all the public SSH keys of the server and store it in a file called known hosts, which can be found under the .ssh hidden folder. Yes, we do trust this server. And after you confirm, you'll be prompted to input the password for root. At this stage, the tables have turned, and it's now the server that wants to know whether it can trust you. Do you know the password for root of this server? Well, prove it. Yes, Mr. Server, I am him. But before we can do anything, let's check out the contents of the known host file. All these are the public SSH keys of the server we just connected to. And to prove to you, let's head over to etc/ssh on the server. This is also where the configuration files of OpenSSH are stored. These are the public keys. Now let me print them out. Now it may not be clear to you from this output, but the public keys are identical. But let me make it more clear to you. The SSH command accepts optional commands that can be run on the server without dropping you into an interactive session. Don't worry if you don't understand the commands I've written. What it essentially does is it prints out all the public keys of the server, stores it in a local file, and then prints it out in a more user-friendly format. Now pause the video and confirm that both of these are the same, except for the ordering, that is. However, there's a better way of listing the public keys of the server, and that is using the ssh-keyscan command provided by OpenSSH. It collects all the public keys of the server and prints them out on the terminal. This is the easiest way to gather all the public keys of the server. Instead of doing this and needing to provide a password, you can do this instead. And the beauty of being able to manually gather all the public keys is that you can also manually build the known host file yourself. To show you this, let me delete the known host file. When I try to connect to the server again, I get prompted for host verification again. Let me cancel that. Now let's manually build the known host file. This recreates the known host file. When I try to connect to the server, we get prompted for host verification. Manually building the known host file comes very handy in certain situations. For example, when it's impossible to provide answers to an interactive prompt, such as when you're building a Docker image. Now let's log in as root again. Now, it's not recommended to allow anybody to log in as root via SSH. While your password may be strong, it's mostly not a worthwhile risk for critical system, as the risk outweigh whatever convenience you will get. It's recommended that you create a non-root user that will only have the permissions and capabilities that you will need. So, let's disable root. But first, let's create a new user that we can use. We'll call her Jade. Now, I have specified the bash shell, but you can choose to leave it blank and use the default shell. Now, let's exit and try to log in as Jade. Success! Jade is up and running. Now let's disable root from logging in via SSH. Switch to root. Open the sshd config file in an editor. I'll use Vim, but a popular alternative is Nano. Find the permit root login option and set it to no. We'll need to restart SSHD so that our settings take effect. Now let's exit and try to log in as root. You will get a permission denied error even if you use the correct password. Root login has now been disabled. Now let's log in as Jade. Oops, wrong password. Yes, got it right. But all this re-entering and re-entering passwords, it's kind of tiring. There must be a better way. This is where SSH key authentication comes in. You generate two keys, a private and a public key. Think of them like two puzzle pieces. You give one piece to the server and you keep the other one to yourself. When you log in, you match both puzzle pieces, and if they successfully match, you're in. You don't have to enter any password. The server knows that it's you. Now, please don't show anyone your puzzle piece. If you do, somebody can impersonate you. Now let's see how it works. OpenSSH provides us with the ssh-keygen command, and it's used to create such a key pair. Let's create one. By default, as of the year 2024, the command chooses the ED25519 key type, which is very secure. The others are DSA, EDSA, and RSA. Now, DSA isn't secure, and most servers don't support it, so don't use it. Let's continue. You will be prompted to confirm the path of the private key. By default, it has chosen the key name of ID_ED25519. This isn't by accident. OpenSSH uses default key names that follow a certain naming convention. Knowing the names of these key types is important to know the default behavior of OpenSSH. Let's accept that name. Now, you will be prompted to add a passphrase. A passphrase is like a password for your private key. No one will be able to use your private key without them knowing the password. But can't they just print out the contents of the private key? Yes, they can. But the thing is, the passphrase is used to encrypt the private key, so anyone who prints them will be wasting their time. A passphrase protects your private key in the event that they are leaked or stolen, thus making passphrases essential to protecting critical servers. But won't adding the passphrase just recreate the same problem of entering and re-entering passwords again? Yes, and thankfully also no. I promise I'll explain how a passphrase isn't actually a problem in the long run. But for now, I'll just leave the passphrase blank. Now let's give the server its half of the puzzle. The server stores the public keys in the authorized keys file in jeds.ssh hidden folder. The authorized key file is like a VIP guest list that the SSHD can use to know which guest can walk straight into the server without being frisked for a password. Unlike collecting the public keys from the server, there is a tedious way of adding the public key to the server's VIP list. After entering the password, the public key is copied from the local SSH folder and appended to the remote authorized key file. Now let's log in. That's it, we have logged in automatically. But remember me saying that this is the tedious method? So let's delete the authorized key file so that I can show you the much easier method. Now, like it has been a theme, OpenSSH provides an easy command called ssh-copy-id that adds our public key to the server's VIP guest list. Let's run it. Notice that I didn't specify a key to upload, but it still found the key. This is because the key pair has a name that follows OpenSSH's naming convention. Now let's apply the password. Done. Now let's try to connect without a password. We are now VIPs. No passwords. Now, there's something I want to show you, but I'll need to delete the authorized key file in order to show you. Let's generate another key, but this time we'll give it a custom name and a passphrase. Now let's upload it. Wait, it didn't find my custom key. This is because our key doesn't follow OpenSSH's naming convention. To copy our key, we must explicitly provide the path to the key. Let's cancel that operation and specify the path to our key. Notice now that it finds our key and only our key. Let's provide the password and try to connect. Wait, what's that? A prompt or a password? Yes, that's a prompt for a password. Remember that SSH doesn't know about our custom key. Let's apply the path to our custom key and try again. Wait, I thought you said no more password. Yes, I did. This is actually a prompt for the passphrase, not Jade's password. The private key is encrypted, remember? Guess who's back on the VIP guest list? But haven't we just shifted from being inconvenienced by entering and re-entering passwords to being inconvenienced by entering and re-entering passphrases? Yes. But here is where I'll fulfill my earlier promise. But first, a story. A lot of high-end restaurants have valets. Valets take away the customer stress of parking their cars as well as getting their cars out of parking. The guests just have to leave their keys with the valet and the valet handles the rest. OpenSSH has a tool that acts as valets for your private keys. That tool is called ssh-agent. SSH-agent, much like SSHD, runs in the background, but unlike SSHD, which runs throughout the whole machine, the SSH-agent only runs in the terminal that you're running. And it's not even started by default. You are the one who decides whether to use it or not. Now, the SSH-agent stores the private keys you give it and hands them to the SSH client when it's needed. This means you only need to add private keys once and use them as many times as you want during that particular shell session. Let's try it out. But let's exit first. The agent is now running. Let's add the key to the agent. This is done by an OpenSSH command intuitively called ssh-add. But let's run it without any arguments. Notice that it only adds ID ed to 5519, but not custom key. Again, this is because one of them follows OpenSSH's naming convention while the other one doesn't. Now, let's manually add our custom key, which doesn't follow OpenSSH's naming convention. Notice that you are prompted to add a passphrase. It's now added. Before you continue, I want you to know that you can list the keys that are managed by the SSH agent. You just have to run this command. It prints out the public keys of the keys managed by the SSH agent. Now let's connect to the server. Guess who's back? No password, no passphrase. For users who handle critical system, the SSH agent makes using encrypted private keys very convenient. Now, with that behind us, let's look at how we can move files between our computer and the remote server. However, some of you may have noticed that we've already been doing that when we were copying the public files from our machine to the remote server. We have used more tedious methods as well as more convenient methods such as ssh-keyscan and ssh-copy-id. This time, I want us to expand the list of tools with even more convenient tools. But first, let me create two files on the remote server. Now, I want to copy these files to my local folder, edit them, and push them back to the remote server. The first tool that I want to introduce is SCP. SCP is a tool provided by OpenSSH. Think of it as the regular cp command that we use to copy files on our local machine. Only this time it has the ability to copy files securely across the internet. Now let's try it out. Let's copy one file from the server to our machine. As you can see, it has copied the file while giving us a progress indicator. Now let's edit it. Upload it. Confirm that it's uploaded. Success. Now the second tool that I want us to use is another tool from OpenSSH called sftp. For those who have used FTP before, this is a secure version of that. It does everything that FTP can do. This makes it a no-brainer replacement for FTP. Let's dive in. This drops us into an interactive session. Let's copy the second file. Now let's edit it. Upload it. Confirm it's uploaded. Success. Now a bonus tool that I want us to try is rsync. Rsync isn't part of OpenSSH, and therefore you'll need to install it separately. I already have it installed. Rsync is a tool for synchronizing files between two locations, regardless of whether the two locations are on the same machine or in two separate machines over the internet. Now, it's the latter case that I'm interested in, as rsync uses SSH to sync files over the internet. The advantage of rsync over SCP and sftp is that while all tools have the same speed when transferring files for the first time, rsync is faster on subsequent transfers as it only transfers parts that have changed, not the whole files. Let's give it a shot. Let's sync the folder containing the two files. This creates a local copy of the folder on our machine. Now let's edit one file. Now let's sync the files again, but this time, have the local files as the source. This is important as having the wrong order will lead to losing your changes. As you see from the progress bar, only one file has been copied as it's the only one that we changed. Let's confirm the changes. There it's it, we've changed it.